When a security operations center, SOC, grows beyond a tiny setup, the biggest day-to-day challenge often stops being a lack of tools and becomes the problem of getting tools to work together without creating new risk. Integration sounds like a technical convenience, but in operations it is really about trust, because you are deciding how data moves, who can see it, and what actions one system can trigger in another. If integration is designed well, analysts spend less time copying details and more time making good decisions, and investigations become faster because context travels with the alert. If integration is designed poorly, you create blind spots, duplicate alerts, inconsistent evidence, and even new attack paths where one compromised system can influence many others. This is why safe integration is a management topic, not only an engineering topic, because the decisions affect confidentiality, integrity, availability, and operational reliability. The goal here is to help you understand how to integrate SOC tools so data flows smoothly while maintaining least privilege, strong governance, and evidence integrity. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to start is to understand what trust means in the context of tool integration, because trust is not a feeling, it is a set of controlled assumptions. You trust that data is accurate enough to act on, that it has not been modified in ways that hide important facts, and that it is coming from an authorized source. You trust that access to data is limited to people and systems with a legitimate need, because SOC data can include sensitive details about users, systems, and incidents. You trust that actions triggered through integration are authorized, traceable, and reversible where possible, because response actions can disrupt business operations if they are wrong. You also trust that the integration itself will not fail silently, because a silent failure can create false confidence and delayed response. When you think of integration as a trust engineering problem, you naturally ask questions about identity, permissions, validation, and monitoring of the integration pipeline. Those questions are what keep integration from turning into a fragile web that breaks under pressure. Safe integration begins with clear purpose, because connecting systems without a defined operational reason tends to create complexity and noise. The purpose should be tied to a service the SOC provides, such as faster triage, richer investigation context, consistent case documentation, or controlled response execution. For example, an integration might exist to attach asset criticality and ownership to alerts, because that speeds prioritization and supports escalation decisions. Another integration might exist to pivot from an alert to endpoint context, because that helps validate whether suspicious behavior occurred. Another might exist to automatically open a case and capture key fields, because that preserves evidence and reduces manual work. When the purpose is explicit, you can decide what data must flow and what does not need to flow, which reduces exposure. This is also how you avoid the mistake of sending everything everywhere, which can flood tools with irrelevant data and increase the risk of leaking sensitive information. Purpose-driven integration is a control in itself because it limits scope, and limited scope is easier to secure. Once purpose is defined, the next step is mapping the data flow, meaning you identify what data moves from which source to which destination and why each movement is needed. Data flow mapping sounds formal, but it is basically the act of drawing a mental line from source to consumer. If an endpoint tool sends alert context to SIEM, what fields are included, how often, and what will the SIEM do with that data? If SIEM sends an alert to a case system, what evidence is attached, what metadata is captured, and what happens when the alert is updated? If SOAR platform pulls identity context, does it retrieve only what is needed for triage, or does it pull full user profiles that expose more than necessary? Data flow mapping forces you to confront what you are exposing and what you are depending on, which is essential for safe integration. It also makes reliability problems easier to diagnose because you know where information should appear and where it could be lost. In mature operations, data flow maps become part of the program's operational knowledge because they explain how visibility is created, A central principle for safe integration is least privilege, because integrated tools often communicate using service accounts, tokens, or application identities that can become high-leverage targets. Least privilege means the integration identity should have only the permissions required for its specific job and nothing more. If a SOAR workflow needs to read alerts and update case notes, it should not have broad permissions to modify system configurations. If a case system needs to receive alerts, it should not have permissions to pull sensitive identity attributes that are unrelated to investigation. If ASIEM needs to ingest logs, the ingestion identity should not have administrative access to other parts of the environment. The reason this matters is that if an integration credential is compromised, the attacker gains whatever permissions it has, and overly broad permissions create massive blast radius. Least privilege reduces that blast radius and limits the damage that can occur from one compromised integration. This is one of the most defensible security choices because it directly reduces risk while still allowing operations to function. Authentication and authorization are also core to integration trust, because you must be sure that the systems communicating are who they claim to be and are allowed to perform the actions they request. For beginners, it helps to think of integration as a conversation where each side must prove identity and must have permission to ask for or provide certain information. Strong authentication reduces the chance that a malicious actor can impersonate a trusted tool to inject false data or trigger unauthorized actions. Authorization design determines whether a tool can read, write, or execute, and those differences matter. Reading data may expose confidentiality risks, writing data may expose integrity risks, and executing actions may expose availability and business continuity risks. A safe integration design often separates these privileges so that the most dangerous capabilities are hardest to obtain and easiest to audit. This separation supports the principle that not all integrations should be equal, because some data flows are harmless while others can cause major harm if abused. When you see integration decisions in exam scenarios, answers that emphasize controlled permissions and clear authorization boundaries are usually the most defensible. Data integrity is another trust requirement, because SOC decisions depend on evidence, and evidence loses value if it can be altered without detection. Integration can affect integrity when data is transformed, normalized, enriched, or deduplicated as it moves between systems. Those transformations can be beneficial, but they must be transparent so investigators can trace what happened. A common operational risk is losing context, such as the original raw event, the exact timestamp, or the source system identity, because those details matter during investigations. Another risk is data duplication, where the same event appears multiple times in different formats, creating confusion and inflating alert volume. A safe integration approach keeps provenance, meaning it preserves where the data came from and how it was processed. It also supports traceability, meaning you can track an alert back to the underlying events and confirm they are consistent. This is why many SOC programs insist on consistent identifiers and stable fields across tools, because stable identifiers support correlation and reduce ambiguity. Confidentiality must also be managed carefully because SOC data often contains sensitive information about people, systems, and security posture. Integrations can accidentally overshare, such as sending full user details to systems that do not need them or exposing incident details to broader groups than intended. This can create privacy concerns, legal concerns, and internal trust issues, especially when data includes employee activity or customer information. A safe approach limits data exposure by sharing only what the receiving system needs to do its job, and by applying access controls and segmentation around sensitive data. It also considers data retention, because once data enters a tool, it may be stored for a long time, and that storage becomes part of the organization's risk surface. Retention must align with legal requirements and operational needs, and it must be consistent with what the organization can protect. This is why data classification and handling rules matter even inside a SOC, because security tools can become repositories of highly sensitive information. Safe integration respects privacy and need to know, not just technical convenience. Availability and reliability are part of trust because an integration that fails unpredictably can create operational blind spots that are difficult to notice. For example, If logs stop arriving at the SIEM, detections may silently degrade, and the team may believe monitoring is functioning when it is not. If the link between the SIEM and case management breaks, investigations may continue in chat threads and become undocumented, reducing continuity and learning. If automation workflows fail mid-process, response actions may be partially executed, which can create inconsistent states and additional risk. Safe integration includes monitoring of the integration pipeline itself, such as health checks, alerting on ingestion gaps, and validation of expected data volumes. It also includes fallback procedures, so the team knows what to do when automation or data flow is disrupted. This is a major management consideration because the SOC needs dependable capability, and integration reliability is part of that capability. In exam reasoning, choosing to validate and monitor the integration pipeline often reflects mature operations thinking. Another key idea is that integration should be staged and tested because changes to data flow can break detection logic, create noise, or remove critical evidence unexpectedly. Even without discussing step-by-step technical configuration, you should understand the operational principle that integrations should be introduced gradually, validated against expected outcomes, and monitored for unintended consequences. This includes validating that alerts still have the necessary context, that case records are created correctly, and that enrichment does not introduce misleading information. It also includes testing that response actions remain authorized and traceable, because a small integration change can create a new path for unintended automation. A staged approach reduces risk because you can observe the effect of the change and adjust before it becomes widespread. It also supports trust because analysts are less likely to ignore alerts when they believe the pipeline is stable and well-managed. A program that changes integrations unpredictably without validation tends to lose confidence quickly, and once trust is lost, it is difficult to regain. Safe integration also requires clear ownership because integration is a living part of the SOC system that must be maintained and improved. When ownership is unclear, failures linger, and teams argue about whether a problem is a tooling issue, a data issue, or an analyst issue. A mature program assigns responsibility for the health of key integrations, including who monitors them, who approves changes, and who responds when pipelines fail. Ownership also includes documentation of how data flows, what assumptions exist, and what dependencies the SOC relies on for visibility. This documentation is not a bureaucratic burden. It is an operational survival tool, especially during incidents when confusion and time pressure are high. If a major incident is underway and a critical integration fails, the team must be able to diagnose the issue quickly and adjust. Clear ownership and documentation support that ability, which directly improves response outcomes. For a manager, this is part of building a program that runs well, because dependable integration is foundational. Integration can also affect detection quality and alert fatigue, because every new data source and every new automation can change the volume and character of alerts. If the SOC integrates a new telemetry source without adjusting correlation and tuning, the SIEM may flood the team with alerts that are technically correct but operationally meaningless. If automation enriches alerts with too much data, analysts may struggle to find the important facts, which slows triage rather than speeding it. If multiple tools generate similar alerts without deduplication and prioritization, the team can become overwhelmed and start ignoring signals. Safe integration includes operational tuning, meaning you adjust rules, thresholds, and routing so new data improves clarity rather than adds noise. It also includes designing enrichment to highlight what matters, such as criticality, owner, and related activity, rather than attaching every possible field. The goal is not maximum data, it is maximum usefulness, because usefulness supports correct decisions under time pressure. When integration is done with this discipline, it strengthens operations instead of exhausting them. One of the most sensitive integration decisions involves automated response actions, because automation can change risk rapidly in either direction. Automating containment steps can reduce attacker time and limit damage, but it can also disrupt legitimate work if the trigger is wrong. A safe approach often uses progressive automation, meaning early actions might be low risk, such as enriching and opening a case, while higher impact actions require human approval or additional evidence. This aligns with the concept of confidence, because you should scale response based on how certain you are that activity is malicious and how severe the potential impact is. It also aligns with risk appetite, because some organizations accept more automated disruption to reduce threat time, while others prioritize stability and require stronger confirmation. The key is that automation must be governed, traceable, and reversible, because response actions should be defensible and auditable. If an automated action disrupts a critical service, leadership will ask why it happened, and the SOC must be able to explain the trigger and the decision logic. Safe integration makes that explanation possible by capturing evidence and approvals in the workflow. As you think about tool integration for the exam, it helps to remember that many questions are testing whether you understand that data flow can create both capability and risk. The best answers usually emphasize least privilege for integration identities, controlled sharing of sensitive data, integrity and provenance for evidence, and monitoring for pipeline reliability. They also emphasize purposeful integration tied to clear services, because integration should solve operational problems, not create complexity for its own sake. When a scenario suggests the SOC is struggling with slow triage, safe enrichment, and better evidence flow may be the right decision. When a scenario suggests inconsistent response actions, orchestration and case integration may be the right decision, but only with strong governance and approval controls. When a scenario suggests missing visibility, validating ingestion and telemetry pipelines may be more important than adding new detection rules. These choices reflect an operational view of integration, which is what management-level security operations is about. By integrating SOC tools safely, you build a system where data and context move smoothly while trust remains intact. Purpose-driven integration limits scope and reduces exposure. Least privilege limits blast radius if an integration identity is compromised, and strong authentication and authorization prevent impersonation and unauthorized actions. Integrity and provenance protect evidence value, so investigations remain defensible. Confidentiality controls protect sensitive information from unnecessary spread, and monitoring ensures the pipeline remains reliable. Stage changes, clear ownership, and disciplined tuning prevent integrations from becoming brittle and noisy, while governed automation ensures response actions are powerful without being reckless. If you can explain these principles and apply them to a scenario, you will be ready for exam questions that blend technology and management judgment. More importantly, you will understand a real-world truth about security operations. The SOC is only as strong as the trustworthiness of its data flow, and safe integration is how you protect that trust while still moving fast.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.